In this video, we will update you on the current status of the NIST engineering analysis and forensic investigation into the condo collapse of the Champlain Towers South condominium in the Miami Beach suburb of Surfside, Florida. Now, a lot of people have been asking me over the few months here, who's in charge of the investigation? Is it NIST? Who is NIST? Why are they involved? Why is there so much secrecy? When are we going to hear updates from them? We don't trust them. They are not giving us information. They tell me, hey, we want answers now. We want them to blame somebody now so that heads will roll now. Well, I will explain to you in this video the current updates as of a couple of days ago and how everything is all congealing together so that you'll be more confident about the engineering process behind this analysis, and hopefully you will not be as anxious and feeling left out and in the dark as to what is really going on. So NIST gave a presentation a couple of days ago at the National Construction Safety Team Advisory Committee meeting, and so we're going to show you some of what they presented as part of this update. The update also introduced a whole new project that has been added to the investigation, and based on what they were discussing in the update, I think they're going to be creating a few more projects as well. But since we get so many questions on this as to why NIST is involved in the first place and how this is all tied in together to the investigation of the condo collapse, why are the federal government involved in the first place? So let's take a quick look here at who NIST is and what is it that brought them into this Miami condo collapse situation in the first place? I mean, why are they here? So to get all of us on the same page with a simple and complete understanding about NIST, let me tell you about them. So NIST stands for the National Institute of Standards and Technology. They're a division of the U.S. Department of Commerce, and they were created back in 1901, so they're basically 120 years old. It's one of the United States' oldest physical science laboratories, and it was created really to improve the U.S.'s second-rate measurement infrastructure. We were lagging behind Europe, China, and other developing countries. We were like the laughing stock. So NIST was created to create much better standards and testing and engineering and all that other stuff. So NIST literally sets the standard for scientific and engineering research, from the smart power electric grids that we have now and electronic health records to they created the atomic clock and all of that other stuff. They do all sorts of research into advanced materials, computer chips. And guess what, folks? Many of the products and material standards and measurement standards which you and I use today, products that rely on NIST technology measurements and standards. So you've been using and benefiting by their research without even knowing it. Why is NIST involved here? So we know who they are and we know what they do, but why are they involved in this fatal collapse of the Champlain Towers South condominium? They're just a bunch of eggheads, right? That set some standards. Why are they here? So probably, I'm willing to bet that almost 100% of you don't know this, but NIST appeared on the scene of the Miami condo collapse within hours. I heard as early as 2 p.m. the next day, meeting with the fire marshals and everybody else, the heads of the rescue operation, but they were here because of the National Construction Safety Team Act, which probably almost 100% of you didn't even know existed. The NCST Act was signed into law back in 2002 by President Bush, W. This act calls on NIST to establish teams to investigate building failures. So these authorities are very much similarly modeled after like those from the National Transportation Safety Board, the NTSB. Those are the guys that investigate the transportation accidents, the bridge collapses and airplane crashes. Whenever you hear, an airplane crash, about 2 years later, you get the final report from NTSB. So NIST will be doing a very similar type thing. And so the National Construction Safety Team Act gives NIST the responsibility to dispatch teams of experts within 48 hours after major building disasters. So under this law, the NIST director consults with the U.S. Fire Administration and other federal agencies, and they're required to make a standing committee of up to 12 people to advise them on carrying out this NCST Act and to review the procedures and stuff like that and issue reports to Congress. So you're probably wondering, okay, this act, how many times has this been done before? Well, NIST has been called in, as far as I can count, about 6 times under the National Construction Safety Team Act. So they've completed investigations so far on the building collapses of the World Trade Center, the Twin Towers. They did another report on the World Trade Center Building 7, and that completed in 2008. But look at these dates. It's often the reports are many years after the actual incident. The Station nightclub fire was a very tragic fire in Rhode Island, and 100 people were killed in a fire there from the Great White Concert, from the pyrotechnics. Of course, everybody knows the Joplin, Missouri tornado in 2011, the deadliest, costliest tornado in U.S. history. They have two ongoing investigations, too, with NIST. And number one, of course, is our current one, the Champlain Towers South condominium in Surfside, Florida, announced on June 30th, 2021. And also, NIST is investigating Hurricane Maria and its effects on Puerto Rico. So what you're looking at here on the screen is known as the National Construction Safety Team Advisory Committee, which I mentioned briefly a few minutes ago. So this is the panel that NIST reports to. This is who they presented to the other day at this conference call. Now, normally, a committee meeting like this would be in a public venue, but due to COVID, they chose to do it as a conference call. Now, I live 3 miles from Marjory Stoneman Douglas High School, where the shooting massacre occurred 3 years ago that killed 17 people. I knew 3 of these students, and 2 of them who were shot. 2 of them were killed, and the other one survived. And I sat in on these public investigation committee meetings for this to provide public commentary and offer suggestions. And so these pictures you see here, this is what it would normally look like at a public commission type meeting. And they reveal very detailed analysis, photo and video and audio evidence, and investigative results that, us and the public don't normally see, because the news kind of filters all of those details out and everything and just gives you a synopsis of what happened during the day. And now I'm going to make a prediction right here and now, folks, that I think NIST is going to have to issue subpoenas probably 2 or 3 times during this investigation. Because here, when I sat in on the Marjory Stoneman Douglas investigation, this is the disgraced former Broward Sheriff's Deputy Scott Peterson. He refused to show up, and they issued a subpoena, and supposedly he refused to even show up to that as well, too. So sometimes these investigative public commissions can get quite messy when people involved don't want to have potentially bad light shined on their misdeeds or their negligence or their inability to maintain a property, for example, which we might end up seeing here during the investigation of the Champlain Towers South condominium collapse. So the first presentation was given by Judith Matrani Reiser. You can see her there. She is the NIST lead investigator on this investigation into the Champlain Towers South condo collapse in Surfside, Florida. So first, what NIST presented was sort of a mini timeline. They showed that this was the press conference that kicked everything off on June 30th, announcing the NCST investigation. And they showed a few pictures from the response effort after the building collapse. They talked about first specimens of the building debris, how they're extracted days after the collapse. They mentioned that NIST is coordinating evidence identification and handling procedures with the Incident Command, which is usually the Miami-Dade Homicide and the Miami-Dade Fire Departments. They mentioned that NIST engineers help identify evidence from a safe distance. So they weren't like in the way. They weren't up on the pile with the rescuers like you see up here. They're standing off to the side looking for key evidence. So they worked with experts from NSF, that's the National Science Foundation, FSU, Florida State University, all these different fire departments and stuff like that, and they supported the remote sensing activities. So what they had done, I don't know if you can see it over here, I remembered seeing pictures of it from our local news, but I think it was right here on the building on the left here on the 87 Park, that's that new condo. Right here on the 3rd floor, it looks like they had set up a bunch of tripods of equipment where they were aiming everything down here and doing the LiDAR and the laser mapping and every other type of sensing they could do to fully digitize the entire property. So here they're showing some of the results. They gave, this screen here was something that we had not seen before. So NIST presented this at the meeting and said this was one of the first outputs of some of the imagery that they've shot there. And this is some of the equipment that I mentioned that was on that patio there of that condominium that was used to take all of these images and other measurements and readings. Okay, now they did say at the meeting that NIST established some evidence tagging protocols with the first responders, and a lot of stuff like this had not even been done before. The complexity of the systems that they used to log the evidence, the software, the databases, I mean, just everything. They talked about all that. Here they talked about the data portal also for the NIST disaster failure studies. So you can go in there if you have any pictures or evidence or ideas that you want to submit. This is where they solicit from the public to send in your ideas to them. But make sure that any pictures and video you send in are your own, that you own the copyright to. Here they basically showed some data flows of what they do with the data once you submit it. And so here they were saying that NIST waited for the collapse site to be cleared and dewatered and safe before they entered down in here to start taking, non-intrusive measurements and things like that. So on this slide here, they were showing us how NIST was conducting visual inspection and non-destructive testing of the slab. So USACE is actually the U.S. Army Corps of Engineers, in case you weren't familiar with that. So then once NIST had access to the site, they began to conduct subsurface investigations, also with the Army Corps of Engineers, and they did some research with Georgia Tech as well. So they reported that their investigation will include recommendations to improve the safety and structural integrity of buildings. So they also there finally announced their plan of how they're going to do these engineering studies here and the analyses. So under the two co-leaders here, what they're doing, there's 6 projects that they're starting. So the first project here will study the building and code history way over here on the left. And then over here, Project 2 will encompass evidence preservation. So where are they going to store it? How are they going to keep it so that it doesn't get damaged? And how are they going to catalog it and everything? Project 3 here will be remote sensing analysis, a lot of it which we started to see some of here in the previous slides. And then Project 4 is material science. So these are the guys that start taking pieces of the material of the concrete and they'll do chemical tests on it, probably advanced life testing on it, all sorts of tests to see, hey, what's the current pH of it? Did the pH drop too much that the concrete got weakened? Was there the appropriate amount of aggregate in the concrete? This, I think, will be probably the most beneficial. And then Project 5, right here, is the geotechnical engineering. That's when they start doing all the tests of the soil. They might start boring down through the concrete and into the soil and start maybe pulling up cores and testing it with audio waves and all sorts of stuff to characterize the soil. Was it suitable to have a building on it? Is there really a problem? Is the water table coming up too high there? That's what these guys will do. And then project number 6 here is the structural engineering. So I think projects 4 and 6 are the two most important ones. The structural engineering, that's where they bring in all of their smart structural engineer guys that will look at it and say, hey, was the right amount of rebar rods put in these columns and the slabs? Why did we have that punching shear going on over by the pool deck? How does one column falling pull down an entire building? Which that's a question I get asked all the time. So we're getting ready to put a video out on that one as well, too. Okay, and then here they talked about the importance of collaborate, coordinate, and cooperate, and said that all of these people here that you see in this chart need to all work together for this to come out perfectly. You don't want to have to go subpoenaing people. But like I predicted earlier, folks, and I'm going to say it again, remember, NIST has subpoena capabilities here under this National Construction Safety Team Act. I expect them fully to be subpoenaing at least 2 or 3 people. Mark my words, you heard it from me first. You're going to find some unwilling participants in this investigation, folks. Okay, so then the associate lead investigator got up and presented so part of the NIST work on the study of this condo collapse is the analysis right here, analysis of demand and capacity. So what they're going to look at was the load demands of the concrete and the capacity of the concrete to handle those load demands. So they're going to analyze over here, you can see analyze the failure data. They're going to look at videos of the failure, eyewitness accounts. They're going to analyze the debris, the observation, blah, 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 and seek a match between what they have, the evidence, and what's going on over here, and what they're thinking is going to be the demand and the capacity. So they'll have to, when NIST analyzes this demand, they have to look at dead loads. They have to look at live loads, wind, thermal and shrinkage, extraordinary conditions like a blast or a vehicle impact. You've heard a million people say, hey, maybe a car hit a column down in the garage, and that is just so unlikely, but they still have to analyze everything, no matter how preposterous it is. Vibrations, they have to look at that too. And that's analysis of the load demand. On the capacity side, they have to look at the original design here. They have to look at the construction as constructed, which is often different from the floor plan plans that you get, and they have to look at the configuration of the materials and everything. They have to look at modifications made over time. And then lastly, they got to look at deterioration, which we saw a lot of in even previous engineering reports from 2018 from Morabito, right? You have to look at material and fatigue and all of this stuff. Okay, so he's showing here the different projects. Remember I showed you there were 6 projects? So he's showing you the main 4 here and how they all kind of work together here, and then the evidence preservation and the remote sensing. So he's showing how everything is working together. So this right here, folks, is our first bird's eye view of what it is that NIST intends to do to analyze this building failure in Miami and tell us how this condominium collapsed. So a lot of people that were like untrusting and saying, well, I don't know what these guys are doing. This is what they're doing right here, right now. So they've got it all down to a science. The recent updates, and he says they've got physical evidence. Yeah, we already know that. They've set up their data processing and infrastructure. They've recruited all of the onboard teams, and there he listed some of the members. They have to develop failure hypotheses. So each of the different projects that you see there, the 6 projects, they are going to all collaborate together with this collapse hypothesis development that you see here in the middle in the green. That's what their main goal is. And this is what they've been starting just only in the past couple of weeks. I've seen it at the site. The geotechnical laboratory work. This is where they're starting to, find out what's going on down on planet Earth, below the building. We want to know what's going on here. Is this thing on a floating lake or what is it? What's happening? And they've already started doing their structural modeling. Now, this is all they showed. They showed this one slide, but you can tell how far along they've come here, folks. They've got all the columns already done. They've got everything built up, and I'm willing to bet they have a lot more data than they're showing in this slide, because if you look closely here you can see the firewall, the big one, the good one that survived, and then here you can see the tiny firewall on the this is the part of the building that collapsed over here. So this red firewall right here, which to me was basically a joke, it's just too small, and this is the stairwell on the other side of the building. This shear wall right here was actually malformed because, to my knowledge, it was built out of concrete block and not enough rebar and poured concrete to really thicken it up. But here's some trivia for you. A lady on the 6th floor, she was down here, but I'm going to show you right up here. Her unit was right here at like 611, and when she felt the building shaking, she goes to run out. She was only living in the building for a month. She didn't know there was this emergency exit right here with the staircase. She had no idea it was there. She ran down the hall and down past the elevators to right over here. Protected was the other emergency staircase. That was the only one she knew of, and she ran down there, and while she was going down is when this part of the building collapsed. Had she gone into that emergency staircase, she would have been dead. Of course, they're going to look at all the codes and standards, and I recognize this because I have a later version of this. I did not want to spend the $250 that the online sites wanted to get my hands on this PDF package for this one here. So these were the standards for making concrete back in 1977. The building was started in 1980, so they would be using the 77 standards. So these guys are on the ball. They sprung the money for it, and they're going to be looking at that. They're going to be conducting interviews with probably anybody and everybody. And remember, NIST has subpoena powers as well if somebody decides they don't want to talk to them. They're going to look at the building code history of the entire area, the buildings, and to see if it was built according to the standards, and check how the standards evolved since then, and inspections and maintenance and all that, and see if any changes need to be made, or if any of that led to the collapse. So right here under next steps, it says continue reviewing all the available documentation. And look here, it says continue interviewing people with historic knowledge of construction in South Florida. So that says to me, interviews have already begun if they're being truthful about this. Looks like they've already begun. They're talking about they're talking about evidence preservation. They want to make sure all of the tagging and everything is done properly, and they want to make sure that everything's organized properly and that the evidence and that everything is stored properly. Now, with a lot of the evidence they have, now they want to determine where was it in the building. Because when you have a pile, now you got to start piecing it together like a massive 3D puzzle. This isn't no simple 500-piece puzzle, folks. This is a massive 3D mystery that they will then have to try to figure out which columns were where and what floor slabs were where. They're going to do more of this geospatial and 3D imaging and stuff like that. They are creating a 3D model, and look what they've done already. So you can see they've already characterized the beams and everything. And do you remember my video the other day with the H-beam? Here's the H-beam. And remember what I said? The H-beam sits on the southern edge of the building, and you can see it going inside there in the bottom. People that were challenging me on my video from the other day saying, oh, you're wrong. The beam is supposed to be, one cell north, and you were wrong, and it fell at such an angle that it moved it one whole cell. I'm like, that's just ridiculous. But here it shows that I was correct in showing you exactly where that H-beam was. So they're talking about the different layers of the tests that they're going to be doing. So they start off with the non-destructive tests first. They do all of these. They're showing you what they're doing. Then they're doing more local tests, and then they may start to, after this, go into more destructive type later on as they need to. And then, of course, with the geotechnical test, they want to evaluate the condition of the foundation here, and that's what they're talking about here. So then in the structural engineering project, they want to use all of the evidence collected from the collapse site. And of course, they can use the results from other projects that they've worked on as well, and in their knowledge of structural engineering and reinforced concrete design. And they will tell us, they'll use models that simulate the failure, and hopefully they'll give us a good 3D model that is based on everything they have found, which will be more accurate than all of the models we've seen so far on the internet. Pretty nice models that other people have done, like Mike Bell, but they may need to be refined with the newer information that NIST has. And then here again, they're showing more of the 3D, and what they want to do is just use these models to determine where was the weaknesses, where was the strengths and weaknesses of this building. And then of course they're talking about project management and budget, and they're talking about now, like, how often does everybody meet? So all these individual project teams here, remember 1 through 6 that I showed you, they will meet weekly. The collective project teams, they all meet weekly. The lead investigator and the associate investigator who presented all of these slides here today, they will meet weekly as well. The investigation leaders, they meet with the director level people and stuff like that, like every 2 weeks, to give them updates. So then they talked about protocols that they need to manage the evidence and stuff like that, and also how to share it and how to keep certain people from getting at certain evidence that they don't need to get at, and process all the data that's collected. So it's just a huge amount of data that they need to collect and figure out how to save it in the best possible way. Well, so that's what they presented at the meeting the other day. As you can see, we didn't get any answers. They didn't give us any, well, here's what we think so far. You'll find that standards bodies and other things like NTSB and NIST, they will not tell you what they think is the cause, because they won't tell you until they know 100% the cause, and they've tested it and modeled it and duplicated it and can turn it on and off like a light switch. So I've been telling this people for years as an engineer at Motorola, when you have a failure mode, until you can control it and turn it on and off like a light switch, that's how you know you've got the right root cause of the failure. And so that's why they're going to be tight-lipped about this. They might give us little snippets and show us, here's some models that we've worked on, blah, blah, blah. But typically, you're not going to see a whole lot until they have the final report. So we hope you have found this video today informative, and I hope that it makes you feel at least a little bit more confident about the information that's out there right now, what's going to be done into the investigation. And I know this was lengthy, and thank you so much for hanging out to the end, but there's a lot of important information here. And remember, we were recapping a half-day long presentation. I took that whole presentation and put it into this short, half-hour or so long video. So that crunches everything up together and makes it a lot quicker for you and gets the information out to you in a way that you can understand it. So thank you for tuning in today, folks. Make sure you're subscribed with the alerts turned on so that you'll be alerted the next time we come up with our next video for you covering this important topic. Thank you so much for joining us today, folks, and we'll see you all on the next one.